Hey, welcome back. We're going to move on to lesson 1.2. There are two videos for this. This is part one. I'm trying to make them smaller. We're going to learn how to classify real numbers. So we're going to have to learn some terms here. These are going to be part of Quizlet. All right, so when you read this Venn diagram, this is a Venn diagram, you want to start with the smallest box. That's the natural numbers. Those are how we naturally count. 1, 2, 3, 4, 5, 6, and so on. It just keeps going on and on and on and on. All right, that's the natural numbers, the counting numbers. Then, as soon as we add a 0 to the mix, that becomes the set of whole numbers. So notice that the naturals are included, are like contained, that box is contained completely inside the yellow box. So the whole numbers include all of the naturals and the number 0. So 5, and then it just keeps going. So every natural number is also a whole number. And then the integers, we're going to take every whole number and then we're going to put on it the matching opposite or negative. So we'd have -3 and we keep going out that way. -2, -1. Notice that we don't have like fractions, okay? So every whole number is also an integer. Every natural number is also an integer. Notice that the green box is contained within the purple box for the integers. The yellow box is contained within the purple box for integers, okay? Then we're going to talk, the next thing are rational numbers. So these are your fractions. Well, if we have an integer over an integer, -2 over 10, okay? We could also have 1/2. Anytime you have an integer over an integer. You can also have terminating decimals, like 0.25 or 0.50 or 6.125. Okay? We can also have up here, we can have improper fractions like 23 over 3, integer over an integer. Okay? And then we can also have repeating decimals like 0.1212 repeating or 0.3 repeating. Okay? And then every natural number is also a rational number. Every whole number is also a rational number. Every integer is also a rational number. And then rational numbers are also real numbers. So you see how this list is working? Okay, so if you're a natural, you're a whole, you're an integer, you're a rational, and you're a real. If the number is a whole, so say 0, then it's whole, then it's an integer, then it's rational, then it's real. If the number is -10, then it's an integer, it's rational, and it's real. If you have 4/13, then it's rational and it's real. Notice over here we have this thing called the irrationals. The irrationals. These are made up of square roots of non-perfect squares. Square root of 17, the square root of 5, the square root of 2. Anytime your radicand, that number underneath the radical sign, is not perfect, then you have an irrational. We also have irrational numbers that are like pi and e, and we're going to talk about e. Pi you've used. E, we're going to talk about that second semester. In words, this is another representation of what we just talked about, not new information. The natural numbers is the set of counting numbers. Counting numbers. So it's 1, 2, 3, 4, 5, and so on. The wholes are every natural number and then the number 0. So you have 0, and then you have 1, 2, 3, 4, 5, and it keeps going. The integers are all the whole numbers. So you have 0, 1, 2, 3, 4, 5, and then all of their negatives. -5, -4, -3, -2, -1. And these dots on either end say it just keeps going. Then the rationals are the integers, and then any number that can be expressed as a fraction of an integer and an integer. So we could have, like we said, 2/5. Let me get my pen here. 2/5, 9/5, -10/2. Okay. We could have -135/8. We could also have 0.125, and we could have 0.5 repeating. Okay. Then the irrationals are fractions whose decimal points never end or never repeat. So they're the square roots of non-perfects. We talked about that on the other slide. And they are pi and e. And real numbers are the set of all of the rationals plus the irrationals. That makes the reals. So rationals, and remember, rationals are made up of integers and wholes and naturals plus irrationals. So a number can belong to more than one set. So 5 is a natural number because we can count to 5. It's a whole number. It's an integer. It's rational, and it's real. Notice that if it is, I'm going to go back to that picture. If it is on this side, then it cannot be irrational. This line right here separates all of the rationals from the irrationals. Can't be both an irrational and a rational. Okay? So when I classify, I'm going to do kind of a think aloud for you. These are the questions that I'm going to ask myself. Okay? I'm going to start by asking myself, is it that smallest subset? Is it a natural counting number? Well, if it's an n, then we know for sure that it also has to be a w, it has to be a z, it has to be a q, and it has to be an r. So if it's an n, then it's also a w, a z, a q, and an r. Whole, integer, rational, real. If it's not a w, if it's not an n, then you ask yourself, is it a whole number, the w's, right? If it is, then it starts with a W, and it has to be a Z, and a Q, and an R. See how that pattern's working? If it's not a W, then ask yourself, is it an integer, the Z's? If it's a Z, then it's also a Q and an R. If it's not a Z, an integer, then ask yourself, is it rational? If it's a Q, then it's also an R. And if it's not a Q, then it must be an I and an R. All right? So let's go through some classifications here and see how it works. Is 23 a natural counting number? Yeah, I can count to 23. I can count $23. So it's an N. If it's an N, it's also a W. If it's a W, it's also an integer, which is a Z. If it's a Z, then it's also rational, which is a Q. And if it's rational, it's also real. The square root of 50. This is not a perfect square, not perfect. All right? So that means it must be irrational, an I, and real. -4/9. Is that a natural counting number? No. Is it a whole number? No. Is it an integer? Well, there's a negative sign, but this is a fraction, so it's not an integer. And then, is it rational? Yeah, it's a Q and it's an R. -185. I don't count naturally. When I count things out, I don't count -1, -2, -3. So it's not a natural. It's not a whole number. It starts with a negative, so it's going to be a z, which is for the integers. It's also rational, which we designate with a q, and it's also real. So why don't you give yourself hit pause and go ahead and do a couple of these problems and see how you do. Remember to simplify before you classify. All right, I'm going to go ahead and simplify this to -7. Square root of 49 is 7, negative out in front. So this is an integer, z. It's rational, q, and it's also real, r. F, this is not perfect. Ooh. So the only thing it can be is an I, and if this is an I, then it's an R. That does not look very good. -7/8. This is a Q, rational and real. This is a repeating decimal, so that makes it rational and real. Pi is a never-ending decimal, doesn't repeat, so that's irrational and real. And these ellipses right down here say that this number just goes on and on forever. And notice that there is no pattern. So that's an I and an R. Okay? All right. So these is the problem set that we're going to be doing. So go ahead, if you'd like to, you can get started and make sure you check out Quizlet. Thanks. Bye.